Hello everyone. We're doing linear programming, and our first problem here is number 6. You are taking a test in which items of type A are worth 10 points and items of type B are worth 15 points. It takes 3 minutes to answer each item of type A, and 6 minutes for each item of type B. The total time allowed is 60 minutes, and you may not answer more than 16 questions. Assuming all of your answers are correct, how many items of each type should you answer to get the highest score? Always zoom in on the question. How many items of each type should you answer to get the highest score? That is going to be our objective quantity. That is the expression that your corners will be plugged in to help you find the highest score. Well, let's go back to the first sentence. You don't know the number of type A, so say there's X items of type A, and you don't know the number of items of type B, so let's say there's Y items of type B. You are told that each item of type A is worth 10 points. So if you do X of them, you've got 10X points. And each item of type B is worth 15 points. So if you do Y of them, you've got 15 Y points. So here is your objective quantity. This is what you have to plug your corners into when we're done graphing. Next, it takes 3 minutes to answer each item of type A. Well, if you do X of them, it'll take 3X minutes. And 6 minutes for each item of type B. So if you do Y of those, that would take 6Y minutes. So in all, it would take you 3X plus 6Y minutes. Well, the next sentence says the total time allowed is 60 minutes. So that means then that 3X plus 6Y is less than or equal to 60. And it says you may not answer more than 16 questions. Well, you're doing two types. If you do X of type A and Y of type B, you will answer X plus Y questions. And you're allowed to ask no more than 16, which means less than or equal to 16. Now there's two other inequalities that are implied here. You can't answer a negative number of questions. So that means that X has got to be greater than or equal to 0, and Y has got to be greater than or equal to 0. Here is our system of inequalities. Well, we need an x-axis and a y-axis. Let's put our x-axis down here. And let's put our y-axis over here. X is greater than or equal to 0. That means we're going to be to the right of the y-axis. And y is greater than or equal to 0 means we're going to be above the x-axis. That's why we're favoring quadrant 1. It's because of these two right here. X equals 0 is the y-axis. Y equals 0 is the x-axis. So we want to be above the x-axis and to the right of the y-axis, which means we want to be in quadrant 1. Now let's take a look at the first inequality. 3x plus 6y equals 60 is the boundary line. It'll be solid. And if we solve for y, we'd have 6y is minus 3x plus 60. So y is equal to minus 1/2 x plus 10. So the y-intercept is 10. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is the y-intercept. The slope is negative 1/2. So that means you go down 1, right 2, down 1, right 2, down 1, right 2, etc. So here is our boundary line. And we want to shade, if you solve for y here in this same inequality, you'd have 6y is less than or equal to 60 minus 3x. So y is less than or equal to 10 minus 1/2 x. So we want to be below that line. So far we're inside this triangle. But we have one more inequality. X plus y equals 16. When y is 0, well, solve for y. We could use the intercepts, but we'll do the slope-intercept form. The y-intercept is again, oh, well, it's not again. It's 16. This was 10 here. So we got to go 11, 12, 13, 14, 15, 16. Here it is. And the slope is negative 1. So let's see, down 1, right 1, down 1, right 1, etc. So this boundary line is going to go like this. And we want to shade below that line. So that means then that our shaded region, our solution space, is going to be in here. And our corners, there's 4 of them. This one is 0, 10. This one is 0, 0. And let's see, this other one here. Remember, this line is x plus y equals 16. Well, the x-intercept for that line is 16, so this is going to be 16, 0. And now we need to find, and the other line, we don't want to forget him, 3x plus 6y equals 60. We got to find where they intersect. We need that point right there. So let's solve it by linear combination. Well, let's multiply the bottom equation by minus 3. And that would give us minus 3x minus 3y equals minus 48. Add these two. You're going to get 3y equals 12. So y is 4. And if y is 4, plugging in here, you get x is 12. So this point then is 12, 4. Well, now we're ready to plug into our objective quantity. Remember, our objective quantity is right here. So we need to plug that in. Plug in 0, 0, you get c is 0. Let's see, let's use green for that. C is 0 there. If you plug in 0, 10, this point right here, into your objective quantity, you would get 150. And if you plugged in 16, 0, you'd get 160. And if you plugged in 12, 4, let's see, you'd have 10 times 12 is 120, plus 15 times 4 is 60. You'd get C is equal to 180. So the highest score you can get is 180. Now we need to answer that question. Need to get some room here. So that means 12 type A and 4 type B questions. If we answer that many, the max points is 180. So here is the answer.